Part A, Elementary Level. Lesson 1, Human Brain. Passage 1. How does food affect your brain?
The foods you eat supply your body with energy. Your body needs energy to move, breathe, and even to sleep. One part of your body uses a surprising amount of energy. It's surprising because this part of your body is small, only 2 to 3% of your total weight, but it uses 20 to 30% of the energy from your food. Can you guess what it is? It's your brain. No doubt you know that drugs affect the brain. But did you know that food affects it too? Different types of food affect the brain in different ways. Sometimes we can feel the changes that food makes in our brains. For example, most people can feel a change almost immediately after drinking coffee. The caffeine in coffee makes people feel mentally sharper and more awake. After a cup of coffee, a person can think and make decisions more quickly. Other foods affect the brain in ways that we cannot feel, so we aren't aware of the effects. We do not realize how these foods influence us. However, everything we eat matters. Our food affects how smart we are, how well we remember things, and how long we can concentrate. For example, researchers have found that eating breakfast makes students do better on tests. Spinach, berries, and other colorful fruits and vegetables help keep older brains from slowing down. Eating large amounts of animal fat, in meat and cheese, for example, makes learning more difficult. Fish really is brain food. Many people have long believed that eating fish was good for the brain, and now scientists are finding that this is true. For millions of years, the brains of early human beings stayed the same size. They weighed only about 1 pound, 400 to 500 grams. Then, during the last million years or so, there was a big increase in brain size, with the human brain growing to about 3 pounds on average. This increase in brain size meant an increase in brain power. With bigger, more powerful, more advanced brains, human beings became smart enough to build boats and invent written languages. They developed forms of music and began to create works of art. Some scientists say that the big change in the size of the human brain happened after people started to eat fish and other kinds of seafood. Seafood contains a certain kind of fat known as omega-3 fat. According to these scientists, omega-3 fat caused the increase in brain size. Today, brain scientists in general agree. This fat is still important for healthy brains, and most of us are not getting enough of it. Did you realize that your brain is always changing, no matter how old you are? The foods you eat affect how your brain grows, how well you learn, and how well you remember things. Maybe you have never thought about how you feed your brain. Luckily, it's never too late to start feeding it well.
Passage 2. How does your memory works?
You have 2 basic types of memory, short-term memory and long-term memory. Things you see or hear first enter your short-term memory. Very little of this information then passes on into your long-term memory. Does this mean you have a bad memory? Not at all. Your short-term memory has a certain job to do. Its job is to store information for a few seconds only. You use your short-term memory when you look up a phone number, call it, and then forget it. You remember the number just long enough to use it, and then it disappears from your memory. That's really a good thing. Imagine if your memory held every number, face, and word you ever knew. Your brain would hold a mountain of trivia. Of course, we need to remember some information longer, so it has to pass from short-term to long-term memory. Sometimes we tell ourselves to remember, okay, don't forget 555-1212, 555-1212. But usually, we don't even think about it. Our brain makes the decision for us. It decides to store the information or let it go. The brain seems to make the decision by asking two questions. Does the new information affect our emotions? Does it make us happy, sad, angry, or excited? Does the new information concern something we already know, so our brain can store it with information that is already there? An answer of yes to one or both of these questions sends the new information into long-term memory. That means the brain creates new connections among brain cells. These connections form in a region of the brain called the cerebral cortex. It's the largest part of the brain. After a piece of information enters your long-term memory, how do you get it back? Sometimes your brain may seem like a deep, dark closet. You open the door to look for something. You are sure it's in there somewhere, but you cannot find it. Maybe the information is no longer there. Information disappears when connections among brain cells become weak. They get weak if time passes and the connections are not used. That is why it's good to review your notes from a lecture soon after the class. Do not wait too long to look in the closet. To keep the memory of something strong, think of it often. For example, look at those lecture notes the next day and the day after that, too. Then wait a few days and review them again. Every time you think about something, the connections in the brain get stronger. Then it's easier to remember the information when you need it. Unfortunately, this advice applies only to certain kinds of things that you try to remember. It won't help when you are trying to remember a name that's on the tip of your tongue. A tip-of-the-tongue experience is the feeling that you're about to remember a word, but it just won't come out. These experiences are common among older adults, but everyone has them. College students, on average, have 1 or 2 a week. This advice also won't help you remember something that just never made it from short-term to long-term memory. No matter how hard you try, you won't find it in your memory. So you'll need some other strategy to help you figure out where you left your keys.
Passage 3. What happens in your brain as you sleep?
Human beings, like all mammals, need sleep. Adults need an average of 7.5 hours a night. However, the average amount of sleep might not be right for you, just as the average size shoe might not be right for your foot. The usual sleep schedule, that is, doing all your sleeping at night, might not be right for you either. Getting some sleep during the day may be exactly what your brain needs. We may not all need the same amount of sleep or the same sleep schedule, but everyone needs the same two types of sleep. Our sleep is divided between REM sleep and NREM sleep, which you can pronounce NREM or non-REM. REM comes from the words rapid eye movement. During this type of sleep, your eyes move quickly. This eye movement shows that your brain is very active and you're dreaming. You spend about 20% of the night in REM sleep. NREM means non-REM or no eye movement. This type of sleep has 4 stages. When you fall asleep, you enter stage 1 of NREM sleep. This is a light sleep, so a noise could easily wake you up. After several minutes, you enter stage 2. It's not so easy to wake you up from this type of sleep. Stages 3 and 4 are periods of deep sleep. You breathe slowly, your muscles relax, your heart rate slows, and your brain becomes less active. You experience both REM and NREM sleep when you go through a sleep cycle. A cycle is a group of events that happens again and again, like the cycle of seasons that happens each year. A sleep cycle takes you from light sleep to deep sleep and back again. It includes the 4 stages of NREM sleep, then a short period of REM sleep, and finally a return to light NREM sleep. At night, most people go through a series of 4 to 6 sleep cycles. It's good to understand sleep cycles and the stages of NREM sleep if you ever take naps during the day. A nap of 20 to 45 minutes will mean getting mostly stage 2 sleep. It will mean sharper motor skills and a better ability to focus your mind and pay attention. That is exactly what most people hope for when they take a nap. A longer nap may not do you as much good. It may mean that you enter the deep sleep of stage 3 or 4. If your alarm wakes you during deep sleep, you will wake up unable to think clearly. You will probably feel more tired than you did before your nap, and it can take 30 minutes or more to get over this feeling. However, a longer nap can do you good if it covers a full sleep cycle. That takes 90 to 120 minutes. If your alarm wakes you up at the end of a full sleep cycle, you will be coming out of a light sleep, and your brain will have all the advantages of a good rest. Those good effects can last for up to 10 hours. If you live a busy life, you probably do not always get a full night's sleep. Not getting enough sleep can mean you forget words, you have trouble learning, and you react more slowly. You can probably think of other effects of too little sleep. So consider taking a nap for the good of your brain, and think about sleep stages if you set an alarm.
Passage 4. Research on dreaming.
Bruno Beckham has a good job. He also has a new job offer. He has to make a decision right away, but he's not sure whether he should accept the offer. He is sure, however, that he's not going to make up his mind tonight. "I'll know what to do in the morning," he says. How will he know? What does he think will happen overnight? "I don't know," he says, "but whenever I have a big decision to make, I have to sleep on it." When you face a big decision, do your friends tell you to sleep on it? People in Italy say, dormici su. It means the same thing. In France, they say, la nuit porte conseil, meaning the night brings advice. People in many cultures believe that something useful happens during sleep. But what happens, and why? Maybe the answer can be found in our dreams. Many people believe that dreams help us in our daily lives. The American boxer Floyd Patterson believed this. He used to dream of new ways to move in a fight, and he claimed that these moves helped him surprise other boxers. Srinivasa Ramanujan, an important mathematician from India, said that all his discoveries came to him in dreams. Artists, scientists, and writers report getting ideas from dreams, too. The English writer Mary Shelley did. She said that the story of Frankenstein came to her in a dream. Paul McCartney of the Beatles woke up one morning from a dream in which he was listening to music. He immediately went to the piano and played the music, which became Yesterday, one of the Beatles' most famous songs. Scientists do not agree on what dreams mean or why people dream. Some doubt that dreams have any important purpose. They say that dreams show activity in the brain, but it's like the activity of a car going in circles with no driver. It does nothing useful. On the other hand, many scientists claim that dreams are helpful. They say that dreams are good for learning new skills and developing strong memories. Some researchers hope to learn more about the dreams of people by studying the dreams of animals. At the Massachusetts Institute of Technology, MIT, scientists have studied the dreams of rats. In one study, the rats were learning to run through a maze, and the scientists would record the activity in the rats' brains. Later, during REM sleep, the rats' brains showed exactly the same activity. The rats were going through the maze again in their dreams. Researchers could tell if the dreaming rats were running or standing still. In fact, one researcher reported that they could pinpoint where the rats would be in the maze if they were awake. Were the rats practicing for the next day? Does dreaming somehow help them learn and remember? Do human brains work this way? The researchers at MIT are searching for answers to these questions. Right now, there is no explanation for dreams that everyone accepts. There is a great deal we still do not know about the sleeping brain, but maybe one day we will know all its secrets.